So in this lecture we are going to discuss the simple pendulum. All right. So what is the simple pendulum? In class 9, 10th you have seen, right? Also in your physics lab, the simple pendulum is nothing but there is a bob, right, of mass m, and it is attached to a string of length L. This string of length L is inextensible. It is inextensible, right? Inextensible of the length L. Are you getting or not? And this system is called the this is called the simple pendulum. Are you getting or not? So to find the simple pendulum time period, what we have to do, this is the equilibrium position. What is the meaning of the equilibrium position? Net force on this is 0. What does it mean? So mg and tension will be the same. So you tell me, if you give the small displacement like this, small displacement to this block, the small displacement mean this is theta. Theta is small. You have to remember it is small. For the small, sin theta is approximately theta is equal to tan theta. You must remember. Understood? So this is the bob of mass m, and you have given a small angular displacement. Suppose this distance is x is also small. So if you give small displacement and release, then what will happen, you tell? It will oscillate like this. About its mean position, it will start oscillating like this. Are you getting or not, you tell? Fine. It will oscillate like this. Are you getting or not? So to show that its motion is SHM, you have to give the small displacement from the mean position and you have to find the restoring force. Here mg and this is theta. So if this distance displacement is x, so this is mg cos theta and this is mg sin theta. Are you getting or not? So you tell me, this is the mean position or equilibrium position, you can say. So what is the net restoring force? Restoring force towards mean position, Yes, tell me, what is the restoring force? If you have given the displacement in this direction, this is the x displacement, right? The mean position is this, and the net force is acting towards mean position is mg sin theta. Are you getting or not? Right. Again, if theta is small, so it may be written as small theta minus m into a. Why? Because the displacement in this direction, the net force is in this direction, so its acceleration will be in this direction. Will cancel out, minus a g. What is the angle? If the length of the string is L, the angle is equal to arc upon radius. This is the arc upon radius. So what is the theta? Is equal to x upon L, right? So here you can write this g by L into minus x. So acceleration is proportional to minus x. Since here acceleration is proportional to minus x, therefore motion is SHM. And if motion is SHM, you can compare with the standard equation of SHM. This is the 2, this is the 1. So what is the omega square? Say g by L. Omega is equal to g by L is equal to 2 pi by t is equal to 2 pi root L upon g. This is the time period of the simple pendulum we have found because it is performing SHM, right? Time period depends upon the length of the simple pendulum. Also it depends upon the acceleration due to gravity, right? In the spring block system or spring pendulum, it does not depend upon g, but here the time period depends on g for this simple pendulum. All right, copy this. So you can check, time period depends upon length, also depends upon the acceleration due to gravity. Are you getting or not? That is the thing, right? If t is proportional to length L, So can you make the graph between the time period of oscillation and square root of L? Yes, we can make. What is the graph? Say it is the straight line. Sometimes they also ask the graph between the T and L. So how to draw the graph between T and L? This is T square is proportional to L, right? Like y square is proportional to X. Y square is equal to 4ax. I think you know the graph of the y square is equal to 4ax. The graph of y square is 4x is like this. So what is the graph between T and L? Time period is 2 pi root L upon G. The graph will be like this because time period is what? Always positive. So this is the graph between T and L. Is it clear or not? You tell. Listen one thing. If this is the earth, right? This is earth and this is moon, right? This is moon. So if there is a simple pendulum over here on the earth, the acceleration due to gravity is G, its length L. So its time period will be 2 pi root L upon G. But on the moon, if same simple pendulum is taken, right? So the acceleration due to gravity over here is G by 6. Are you getting or not? So time period will be 2 pi root L upon G by 6 is equal to 2 pi root 6 into L upon G. So this is root 6, right? Root 6 time 2 pi root L upon G, which is equal to what? Say root 6 into T. So what is the T dash? Say T into root 6. On the moon, the time period is increase for the same simple pendulum. Are you getting or not? Please tell. Right. So on the, while if you consider the spring mass system over here, this is the spring mass system or the spring pendulum. Time period is 2 pi root m upon k. If it is taken to the moon, tell me, what will be the time period of spring pendulum here? It will be the same. T dash is equal to T. It does not depend upon G. So for simple pendulum, the time period is change, but for the spring pendulum, the time period remain same. Right? Copy this. So as I told you, the time period depends upon the acceleration due to gravity. Right? You can take few illustration. For example, if this is a lift, right? This is the lift, and this is the simple pendulum hanging, right? And it is at rest. If lift is at, what is the time period? The length is L. Say it is 2 pi root L upon G. Are you getting or not? And you are sitting in the lift. Now, if the lift start moving up, with the acceleration, this is the lift and the acceleration is upward direction. So if this is the simple pendulum, tell me, and you are sitting on the lift, this is given a small displacement, so then it will start oscillating. Here if you give the small displacement, it will start oscillating. So the time period is 2 pi root L upon G. If it is oscillating, what is the G effective? You tell me. Inside the lift, G effective is G plus A. So the time period will be 2 pi root L upon G effective, right? And G effective value is 2 pi root L upon G plus A. Are you getting? So the time period will decrease if the lift start moving up with the acceleration. In the same way, if the lift is moving down with the acceleration A, right, and there is a simple pendulum, if you give a small displacement, it will start oscillating like this. You are sitting and observing this. So with respect to lift, it will start oscillating. So what is the G effective here? G effective over here is G minus A. Are you getting? So what will be the time period? 2 pi root L upon G effective, and G effective is G minus A. The acceleration due to gravity is decreasing, so time period is increasing. Is it clear or not? But if due to some reason the wire of the lift is what? The wire of the lift is, suppose this is the lift and this is the string of the lift and it is break, right? It is broken, suppose. Then what will be the time period of this simple pendulum for small oscillation? You tell. You are observing this. If it is broken, what will be the acceleration? The acceleration of the lift is same as the acceleration due to gravity. So what will be the G effective? G effective is G minus A, G minus G, right? So it is 0. So what will be the time period? 2 pi root L upon G effective, right? And G effective is 0. So 1 upon 0 is what? Say infinite. So time period for this will be, will this be infinite? Are you getting or not? What does it mean? The infinite time period. Infinite time period mean you are sitting in a lift and this is a simple pendulum and it is moving, free fall is occurring. This is free fall occurring. So if you give a small displacement, right, a small displacement, it will remain on its position because the G effective is what? Say 0 with respect to lift. So if you give the small displacement, then what will be the net force? No gravitation force, no restoring force. This bob of mass m, bob will remain on its on position, right? That is why it cannot move a little bit. Rather, where it is released, it will remain if it is freely falling with respect to lift, and with respect to ground it is coming in a straight line. All right, so that is why the time period comes to be infinite. This is the meaning of the time period to be the infinite, mean it does not move a little bit. That is why the time period is infinite, right? Theoretically, copy this. So it depends upon the G, right? If G is changing by anyhow, you will get the changing in the time period. For example, I had discussed in the spring block system also. If suppose this is the car or cart, you can say, and if this is the spring block, this is the simple pendulum hanging, right? The length is L and you are sitting over here. If you displace little bit, so what will happen? You tell. It will start oscillation and the time period will be 2 pi root L upon G if cart is at rest. It rests or moving with constant velocity, Is it clear or not, you tell? If moving with constant velocity mean acceleration is what? It's 0. Is it clear? Now, if this cart is start oscillating, right? If cart is oscillating with acceleration A in forward direction, and you are sitting over here, if you consider a mass m, so with respect to mass m, how many force will act upon this? In this case, it was the mean position. Mean position mean if it is at rest, right, no displacement is there, the tension will balance the mg. But if it is oscillating, the force will be acting. This is the pseudo force and this is the mg. And because of this, if suppose it is hanging from the rope, because of this pseudo force, it is start moving in this direction till the net force on the block is on the bob is 0, right? So therefore it is start moving in this way. Listen one thing, it is start moving in this way such that after some angular displacement alpha, this is the pseudo force, you can say. The pseudo force may be represented by the dot line, right? Because it is an imaginary, or right, the pseudo force it is. That is why it is represent due to this dot line. So this is mg. This is the equilibrium position. Now it is at rest. Are you getting or not? This position is the equilibrium position. This is the equilibrium or mean position, you can say, such that the tension in the T dash and MA and MG, because of all three forces, the net force is 0. In this case, if you cut the string with respect to lift, with respect to car, it is moving with acceleration a. If you cut the string, where the particle will move? The particle will move in this direction. So in the same way, if you cut the string at this point, the particle will move in this direction. What will be the force? If you cut the spring, only the mg force will act. So what the acceleration here? Acceleration is net force divided by mass m. So the net force is what? Say mg upon m. So acceleration is equal to c. So in this case, the g effective is g only, right? It is g. But when you will cut the string, it will start moving in this way. What will be the net force in this direction, you tell? The resultant of ma and mg. So the net force will be equal to square root of mg square plus ma square. So the net force is g square plus a square. According to Newton's second law, net force is equal to what? Ma dash. This acceleration a dash will be equal to what? This is m, will cancel out. So the acceleration will be equal to what? G square plus a square. This is nothing but called the g effective in this case. G effective is g square plus a square. Are you getting or not? Right. So now, although it is the mean position, look, when a car is moving in the forward direction with acceleration a, with respect to car, the block will be equilibrium in this way. Why? Because ma and mg are acting and it will be equilibrium. What will be the angle alpha? Right. This angle alpha, if they ask in the Newton's law of motion, the tan alpha value we have found. What is tan alpha? Perpendicular upon base. The tan alpha perpendicular upon mg. So the alpha is equal to tan inverse a by g. Is it clear or not, you tell? So this is the equilibrium position. Now this is the equilibrium position. If this is the equilibrium or mean position, right, now you will give a small angular displacement either left side or right side. If you give the small angular displacement, this is suppose theta, so then it will start oscillating about its mean position like this, right, like this. It will start here. This is the mean position. This is the oscillation of the simple pendulum. Here, this is the mean position. This time, it will start oscillation. So this theta is the angular displacement given by you, right, to prove this SHM. Although we have proved that t is equal to 2 pi root L upon t dash, here 2 pi root L upon g effective. Can you tell me what is the g effective in this case? Yes, if you cut this spring, what is the acceleration by which it will move? This is the acceleration. So t pi is equal to root L upon root over g square plus a square is the time period in this case. It may be written as t is equal to 2 pi root L upon root over g square plus a square raised to the power 1 by 2. So this is the time period of the oscillation, right, of the simple pendulum in the car if it is accelerating with acceleration, right? Copy this. So now we consider a very important illustration, right? As you know, the time period depends upon the 2 pi root L upon g effective. If the g effective is changed, then the time period will be changed. Suppose this is the simple pendulum of the length L. So what will be its time period? T is equal to 2 pi root L upon g. Suppose this is the bob of mass m over here, right? Now, if this bob of mass m is dipped in a liquid, right, like this, suppose this is the iron block or some heavy block is over there, and this is the density of the liquid rho L and the density of the solid is rho S. When it is oscillate in the air, right, its time period will be what, right? T is equal to 2 pi root L upon g. Now, if it is oscillate in the liquid and the density of the solid is greater than density of liquid, first of all, right, if it is displaced a little bit, it will start oscillating. So now the time period will be equal to 2 pi root L upon g effective. Yes, tell me how to find the g effective in this case. Listen one thing, to find the g effective, if you find here, as I told you, this is the mean position, also here it is the mean position. Are you getting or not? Mean position mean it is at rest and net force on the body is 0, right? And if it is mg and t, when you will cut the spring force 0, so mg will acting mg upon m, the acceleration is g. To find the g effective over here, you find this string, you cut this string. When you cut this string, right, can you tell me how many force will act upon this? Right, the force will be mg and one more force, please tell, the Buoyancy force will be acting, and it will come down with some acceleration a dash. So this a dash is nothing but the g effective we will consider. Are you getting or not? So here, to find the g effective, I will apply the net force is equal to m into a dash. What is the net force? You will say the mg minus bind force is equal to m dash. What is the bind force? You will tell this is the weight of the liquid displaced. Suppose m dash g is equal to ma. If you take the mg common, 1 minus m dash upon m is equal to m into a. What is m dash g? Tell me if you remember. This is the weight of liquid displaced. Weight of liquid displaced. And you tell me, what is the m dash? The mass of liquid displaced. What is the mass m dash? Volume into density. Whose density? Liquid density. What is m? M is the mass of solid. What is that? Volume into density. Whose density? Solid density. So this mm will cancel out. The acceleration will be g1 minus, in place of m dash, the mass of liquid displaced, volume into density of liquid, volume into density of solid is equal to a dash. So the a dash is g1 minus rho liquid upon rho solid. This is nothing but the g effective, right? When the string cuts, it will move, right, under the gravitation force and the bind force. So this is the g effective. In this case, the time period of oscillation, if it is displaced little bit, it will start oscillating like this. Are you getting? Time period will be L upon, right, g1 minus rho liquid upon rho solid. So this is the time period of the bob in the liquid of density rho L, while its density is rho S, rho solid, right? Copy this. So now I am explaining this once again. And previously we have seen the time period is what? 2 pi root L upon G. Now we will discuss the second pendulum. What is the second pendulum? Whose time period is 2 seconds, right? If the length is L, if we want to find the length of this second pendulum, if you displace this, it will complete its oscillation in 2 seconds. So t is equal to 2 pi root L upon G. This t is 2. It will cancel out 1 upon pi root L upon G, make the square. So the L is equal to G upon, right, G upon pi square, and G and pi r square approximately are equal. So length of the second pendulum is 1 meter, you have to remember. All right, now see the time period of pendulum, right, pendulum of infinite length, pendulum of infinite length. Infinite length means the length tending to infinity. This is a very important concept. Suppose this is the earth, right? So, have you seen the pendulum in your physics lab? Yes, it is the length of the pendulum may be 1 meter, 2 meter, 3 meter, 5 meter. The 1 kilometer cannot be. So this is the hypothetical question or imaginary question, you can say. So if this is the radius of the earth and this is the simple pendulum and the length is supposed to be capital L, this length of the pendulum is very, very high, very, very large as compared to the radius of this earth. Now if this bob is displaced little bit and it is released, right, then it will start oscillating about its mean position like this. Are you getting or not? So what you have to do, you have to find its time period. You understand or not? So how to find this time period? Let me check. Suppose this is the ME. So this is the small displacement. Suppose this is the alpha, right? This is the small displacement, small. You assume the angular displacement is theta. So you tell me what will be the force acting over here, say mg, right? Although it is shown very big, but it is a small displacement, mg, right? So you tell me, if this is the small displacement, this is the small linear displacement, the length is L, right? This length is L, and this radius, this distance is RE. Can you tell me this angle is alpha? Suppose this is alpha and this angle is beta. Are you getting or not? This is the triangle. This is the triangle, right? So this alpha and theta are not equal. First of all, you must understand, right? I'm making the figure once again. Suppose this is the earth, this is the simple pendulum, the small displacement is over here, this is the point of suspension, like this is the mg. Suppose this is alpha, you assume this is beta, right? So this angle is supposed to be theta. So if this is mg, so the restoring force will be equal to what? Tell me. Mg, this is the mean position, the restoring force is mg sine theta. Are you getting or not? This angle is supposed to be theta. The gravitational force applied on mass m by the earth center is mg. So mg sine theta is the component. Are you getting or not? This theta is not equal to alpha. First of all, you must know. Now, what is the relation between theta, alpha and beta, you tell? Right? If you consider this is the triangle like this, if it is alpha, it is beta. So the sum of the interior angle is equal to the exterior angle. That is, this theta is equal to what? Say alpha plus beta, if you understand. And the restoring force is mg sine theta. So you tell, if I assume this is to be x, this is re, right? This is L. So angle is equal to what? Angle is equal to arc upon radius. Arc upon radius. And what is beta? Angle is equal to what? Say arc upon radius. This is RE, right? RE. Is it clear or not? So here the theta is equal to alpha upon beta, that is x upon L plus x upon RE. This is the angular displacement theta. So now you can write restoring force. What is the restoring force? Restoring force is mg sine theta, and this theta angle is very small, right? Theta angle is approximately theta. In place of theta, I can put x upon L, x upon RE. Fine. The mass is m, displacement in this direction, restoring force in this direction. So acceleration is opposite to the displacement. This is the displacement, this is the acceleration. Net force is equal to m into a. So acceleration is equal to, right, 1 upon L plus 1 upon RE. Mm will cancel out, g over here, and this is x. So what can you write here? The acceleration is equal to 1 upon L plus 1 upon RE into minus x. So here the acceleration is proportional to minus x. So therefore motion is SHM, right? So this oscillation is what? This oscillation is SHM. So therefore compare with the standard equation of SHM, the omega square is equal to g upon L 1 plus RE. Omega is equal to g 1 upon LE 1 upon RE is equal to 2 pi by t. So time period of this pendulum may be written as, right, 1 upon root g 1 upon L plus 1 upon RE. Is it clear or not, you tell? First copy this. So the time period of oscillation you may write like this, 2 pi root. After that it is root over 1 upon G 1 by L plus 1 upon Re. Are you getting or not? That is the thing. Listen one thing. If L is tending to infinity, right? If, for example, if suppose if L is equal to infinity, right? If L tending to infinity, the length is very long. So 1 upon L is equal to what? 1 upon L is equal to 1 upon infinity is equal to 0. So it is 0. So T is equal to 2 pi root 1 upon G 0 plus Re, and it may be written as 2 pi root Re upon G. Right, Re is the radius of the earth, 6400 kilometer, and the G value is 9.8 meter per second square. When you will put the value, right, of Re and G and calculate, this is the important expression, and the time period comes to be 84.6 minutes, right, or it may be written as 1.41 hour, right. So what is the time period of the simple pendulum of infinite length? Is 84.6 minutes. It is the same time period of the oscillation of simple pendulum in the satellite. When we will discuss the gravitation, then the same time period comes in the satellite, right, of the simple pendulum, right. You have to remember this data, right. Copy this. So read this question. In this question, simple pendulum is suspended from the lift, right, and this lift is at rest. So when it oscillates, the time period is what? You tell. 2 pi root L upon G. Fine. Now the oscillation they are asking, so that the oscillation upward they are asking, so that, right, the time period here become T by 2. Are you getting or not? Time period become T by 2. So what is the G effective over here? Say G plus A. So T dash is equal to 2 pi root L upon G plus A. And the time period become T by 2 is equal to 2 pi root L upon G plus A. And this is 1 by 2. And what is the T? Original T when it was at rest. It is 2 pi root L upon G is equal to 2 pi root L upon G plus A. Right. So something will cancel out. 1 by 2 is equal to, tell me, 2 pi is cancel out, root L cancel out, 1 upon 2 root G is equal to 1 upon root G plus A, right. So from here the value of oscillation A we can find. Make square and first equal them and then square both sides. 4G is equal to G plus A, so oscillation is 4G minus G, so oscillation is 3G. So what should be the oscillation of this lift? The oscillation of this lift would be 3G, so that now in that time period become half of the time period of that simple pendulum, right. Copy this. So read this question. As you know, the length of the second pendulum of the earth surface, what is that? Is equal to 1 meter. And if this is the moon, what will be the length of the second pendulum? They are asking. What is the second pendulum definition? Whose time period is 2 seconds? 2 pi root length of earth divided by gravitational G at earth, and it must be the 2 second, right. So therefore at the moon also the time period must be 2 seconds is equal to 2 pi root length of moon and length on moon divided by gravitational acceleration due to gravity at moon, right. So both are equal, so therefore 2 pi root length of earth, gravitational constant at earth, acceleration due to gravity, this is moon acceleration due to gravity at moon. So what is the relation? LE upon GE, right. 2 pi will cancel out, square them, and Lm upon Gm. So you tell me, what is the length of the second pendulum on the moon? Gm upon Ge. So length of the second pendulum on the earth is 1 meter, although it is given in the question, but you must remember, right? The gravitational G, value of G on the moon is G by 6. You have to also remember this. So G by 6 upon G. So the answer is 1 by 6 meter. So length of the second pendulum on moon will be equal to 1 by 6 meter, right? Copy this. So read this question. In this question, the length is changed by 4%. The time period of the simple pendulum depends upon what? It depends upon the length. Are you getting or not? T is proportional to root L, right? If a small change is there, a small change in length, right? A small change in length, right? So a small change in length, then if you remember, T is equal to K root L, right? Dt upon T is equal to 1 upon 2 dl upon L. In the error we have done, right? But if you don't understand, then I can explain this once again. Suppose the time period depends upon the root L. So this 2 pi root G may be treated as the constant. Now, if the length is changed, the time period is changed. If a small change in the length, very small change, delta L upon L into 100 is what? Say 4% given. All right. So the time period will be also changed. If the small change is there, then we have to use the differentiation. How it is? T is equal to K root L, right? Take the log both side. Log T is equal to log K into root L, which may be written as log K. K is the constant. Instead of 2 pi root G, we have taken this constant plus log root L, right? Here the log AB. Log AB is what? Log A plus log B. I had applied. So this is the log T is equal to what? Log K. This is root L. Log root L may be written as log L raised to the 1 by 2 is equal to 1 upon 2 log L. Is it clear or not? So it may be written as 1 upon 2 log L. Right? In this way. Now take the differentiation. If y is equal to log x, what is the dy upon dx? You tell. Is equal to 1 upon x. The log x differentiation is 1 upon x, or you may write dx upon x. dy, y is the dy, log x is 1 upon x into dx. If you differentiate this, this is 1 upon t dt. The differentiation of constant is 0. This is 1.1 by 2 log L, as the log x differentiation is what? Dx upon x. So the log L differentiation is dl upon L. Log t differentiation is dt upon t. So here we will get the dt upon t is equal to 1 by 2 dl upon L. Are you getting or not? So if you multiply by 100 in both cases, in both sides, so dl upon L into 100 is equal to 4%. So this is equal to what? 2%. So the percentage change in the time period is 2% if length is changed by 4%. The change in length dl upon L multiply by 1 by 2. This is the relative change in the time period. You understand or not? Right. Copy this. Listen one thing. If you don't understand this calculation, I have to give some examples. And that this is the basic concept, right, which will be applied at any chapter. In your practical life also, that formula, this concept may be applied, right? I am giving you example. For example, suppose this is the car of mass m. The speed is v. So its kinetic energy is what? Say half mv square. Are you getting or not? If question is, if speed is increased by 50%. 50%. Find the percentage change in its kinetic energy. Is it clear or not, you tell? The question is clear. This type of question you have done many times. Speed is increased, kinetic energy is increased. So what will, if the speed change is 50%, what is the change in its kinetic energy, you tell? Right? For example, listen one thing. How to find the change in kinetic energy? Listen one thing. If initial kinetic energy is Ke1, final kinetic energy Ke2, what is the change in kinetic energy? Tell me. It is K2 minus K1. I am writing it is K2 and K1. Right? This is the change in kinetic energy. Now, the relative change in kinetic energy. To find the this is the change. To find the relative change, always remember change divided by initial value and then percentage change in kinetic energy. This is the relative change, multiply by 100. This is the very first concept you must understand. Right? Change, relative change and the percentage change. You must understand. So what they are asking in the question, they are asking the percentage change. Percentage change in its kinetic energy. In kinetic energy. Listen one thing. K2 minus K1 upon K1, that is half mv2 square, half mv1 square upon half mv1 square into 100. We are going to find the percentage change in the kinetic energy if the speed is increased by 50%. Listen one thing, if v1 speed is v, initial speed is v, what is the v2 speed? v plus v ka 50%. So it is 1.5 v. You understand or not? So half m will cancel out. v2 square minus v1 square into 100 is equal to 1.5 v whole square minus v square upon v square into 100. It is 2.25 v square minus v square upon v square into 100. It is equal to 1.25 v square upon v square into 100. So this is 125%. So the delta K upon K into 100, that is the percentage change in the kinetic energy is 125%. I think it should be very clear. It is very obvious. You understand this thing or not, Varsha? Please tell. Right, first copy this. So listen one thing. This is not valid for only kinetic energy, for any quantity, whether it is momentum, right? Initial momentum is P1, final momentum is P2. So what is the change in momentum? P2 minus. What is the relative motion? Relative change in momentum? P2 minus P1, and this is the percentage change. Any quantity, your weight, M2 minus M1, there is a change in weight, divided by M1, relative change, multiply by 100, percentage change. Is it correct? So in this case, the speed is increased by 50%. Now I am giving you the question. If speed is increased by, if speed is increased by 0.002%, right? Find percentage change in its kinetic energy, right? Copy this and try. Tell me. Okay, if you try to find its kinetic energy in a conventional way, this is the method we use for class, we have used in class 9th and 10th, right? To how to find the percentage of a quantity. I think in 6th or 7th also we use this thing, right? How to find the percentage change. But when as in this case, kinetic energy depend upon the speed v, although here the mass is constant, but the mass may also vary, but now here only the speed is being constant. If it is very big change, then this conventional method we use K2 minus K1 upon K1 into 100. But if the change is very small, like 0.0002%, this method does not work. Then in class 11, we use the concept of the differentiation. How it is used? Suppose this is the kinetic energy, half mv square. This is the question. This is the solution. So this kinetic energy, this is the constant. I will write it is the c into v square. Right? To find the relation between the change in percentage change in kinetic energy and percentage in velocity, take the log both side. This is the method, right? Log, and this is the log c into v square. I think you understand log AB is equal to log A plus log B. This is the v square. It comes in front of this, right? Log kinetic energy. Now you have to take differentiation. Although differentiation is a very big chapter, but here you must understand, again I am telling, if this is log x, dy upon dx is equal to what? 1 upon x, right? So dy is equal to dx upon x. So what would you say? The differentiation of log x is, say, dx upon x. You understand or not? In the same way, differentiation of log kinetic energy, 1 upon ke, right? I am writing this simple k, right? It is k dk. You tell me, log k, differentiation is dk upon k. What is the constant differentiation? 0. This is 2 into, what is the differentiation of log v? dv upon v. Because log x differentiation is dx upon x. Are you getting or not? This is the relative change in the kinetic energy is equal to 2 times of relative change in the speed. For a small change in the speed, we will use this expression, relation, for finding out the percentage change. This is the percentage change. So what is given? The 0.02% is the change in speed. So 0.002, it means the change in the kinetic energy is just double, dk upon k into 100. Are you getting or not? You tell. Please tell the solution. Right? Otherwise, in the conventional way, using this, you cannot find the solution. So when the change is very small, right? 1%, 2%, 0.5%, 3%, 4%, right? Up to 5%, you can apply this method and the answer will be approximately very good. Same. It's the correct answer, right? You can copy now. So let us see some different thing also. In this case, only the speed was changing. Suppose now in the second question, the mass is also changing. Suppose the mass is changed by 1% and the velocity speed is changed by 2%. Then find percentage change in its kinetic energy. It is possible or not? Suppose the mass is changing, the speed is speed is also changing. How to find the percentage change? The change in the mass and the speed is small. So we will use the differentiation. How it is? Suppose the kinetic energy K, I am writing it is K is equal to half mv square. So now the m is not constant because it is varying. Take the log 1 by 2 plus log m plus log v square. You are getting this thing or not? You tell. Varsha, please tell. And this 2 comes in front of this. Now take the differentiation. Differentiate, right? So what is this? dk upon k. Its differentiation is 0. dm upon m, 2 dv upon v. Is it clear or not? So to find the percentage change in the kinetic energy, multiply by 100 into 100 plus 2 into dv upon v into 100. If this is the percentage change in the m, it means dm upon m into 100 is equal to 1. It means is this. If the speed is changed by 2%, it means dv upon v into 100, it is 2. So it is equal to what? Say 1 plus 2 into 2. So what is this? 1 plus 4 is equal to 5%. So what is the small percentage change in the kinetic energy? Say 5%. You understand this thing or not? Please tell. Varsha. Right. Listen, one more thing. I am giving you one more example. For example, if this is the quantity, the x is the quantity which depends upon a square, b cube, right? C ki power 1 by 2, suppose. Are you getting or not? If there is a percentage change, dA upon A into 100 is equal to 1%, percentage change dV upon B into 100 is equal to 2%, percentage change in quantity C is equal to 4%. Find percentage change in X. You understand this thing or not? X depends upon A, B, C. So if A, B, C are changed by some percent, so X will be changed. So how to find the percentage change? Take log. If you take log A square, log B cube plus log C ki power 1 by 2. So it's to be log A, 3 log B plus 1 by 2 log C. This is the log X. Are you getting or not? Differentiate with respect, differentiate it. So dx upon x, 2 into dA upon A plus 3 dV upon B plus 1 by 2 dC upon C. Multiply by 100 each side. You will get the percentage change dx upon x into 100 is equal to what? 2 into. What is the dA upon A into 100? It is 1, it is 2, it is 4. So 2 plus 6 plus 2, it is equal to 10%. So percentage change in x, right, is equal to what? 10%. I think you are getting the concept, right? Copy this. So now let us consider another example. For example, if this is the simple pendulum, the length is L, T is equal to 2 pi root L upon G, right? Find percentage change in its time period, right? If, right, change in length is changed, if percentage change in length is first 11%, second 1.1%. These are the two questions. In first case, the length is changed, length is increased, not change, by 11%. In second, 1.1%. Right? So copy this and tell me the answer. So let's see how to solve this question. You tell me, the percentage change is very big, 11% is sufficient, right? So then the T1 is what? Say 2 pi root L upon G. T2 is what? 2 pi root L dash upon G. Because length is changed. What is L dash? L plus 11% of L. Wait for 1 minute. You may write this the 21%. Please change. This is 2.1%. Right? Please change this. It is 21% change. It is 2.1% change. So if you write this 21, because the answer will be good, right? So this is 121 L upon 100. So this is the L dash. You understand or not? Now, how to find the percentage in the time period? T2 minus T1 upon T1 into 100, we have to find. What is the T2? Say 2 pi root L dash upon G minus L upon G upon 2 pi root L upon G into 100. Right? Root L dash minus root L upon root L into 100. What is the L dash? It is 121 upon 100 into L minus root L upon root L. So root L will cancel out, right? It is root over 121 upon 100 minus 1 upon 1 into 100. How much it is? 11 upon 10 minus 1 into 100. Are you getting or not? So this is how much? 1 upon 10 into 100, the 10%. So 10 time period is changed by 10% if length is increased by 21%. Is it clear or not? This is the solution. This is the first part. But if the change in length, that is dl upon L into 100 is equal to 2.1%, we cannot use this method. Otherwise, their answer may be found accurately with the help of the calculator. You cannot calculate, right? But without calculator, this is the beauty of the differentiation and integration of the mathematics. This is the purely mathematics, right? Mathematics is used to make the calculation simple, right? So in the second part, t is equal to what? 2 pi root L upon G. T is equal to, T is proportional to root L. T is equal to C into root L, right? Find the relation. How? Log T is equal to log C into root L is equal to log C plus log root L is equal to log T is equal to what? Log C plus 1 upon T log L. Now take the differentiation. If you differentiate dt upon T, 0, 1 by 2 dl upon L. So dt upon T into 100 is equal to 1 by 2 dl upon L into 100. Right? It is 1 by 2, dl upon 100 is 2.1. The answer is 1.05%. So this is the percentage change in the time period into 100. It is clear or not, you tell? Right? So this is not used always, first of all. Right? When the percentage change is high, you have to go through this directly method. Otherwise, what should be the answer? It is 1 by 2. The answer should be 1 by 2 into 21. So 10.5. So it is 10%. If you use this method for this, the answer is 10.5. And there will be option whether 10.5 or 10. So you have not to use this method if the percentage change is high. That is the thing. Right? Copy this. So read this question. I think you can do. Scientists measure the time period of the simple pendulum in a lift which is at rest. Right? What is the simple pendulum time period? Say 2 pi root L upon G. If it moves up, right? If it moves up, so what is the G effective in this case? Say G plus A. 1/4 of the acceleration due to gravity. So this is the 5G by 4. So what will be the T dash? 2 pi root L upon G effective. So it is 2 pi root L upon 5G by 4. Right. So it is 2 pi root 4 upon 5 L upon G. So it may be written as 2 into root 5 multiplied by 2 root L upon G. And this is equal to T. So 2 upon root 5 into T. So what will be the T dash then? 2 upon root 5 into T. So the D option is the correct option. Copy this. So read this question. In this question, suppose a simple pendulum is given, right? And this simple pendulum has, if it is released from rest, right? So it will oscillate like this about its mean position, right? The length is L. So the time period is what? This is the mean position, 2 pi root L upon G. Is it clear or not, you tell? Right. Now listen one thing. Instead of this free oscillation, the thing is that there is a support over there, right? Like this. There is a support like this. Are you getting or not? If you consider this is the simple pendulum, right? Like this. Suppose this is the simple pendulum. Are you getting or not? This is the simple pendulum. So if it is oscillating like this, so now there is a point. This is the obstacle. Now, because of this obstacle, here it moves free. But now, because of this obstacle, they start oscillating about this position. Right? So this time period is for complete length. Now again it move of the length L by 4. You understand or not? So this is the thing, right? So we have to find total time period. You can assume there is a nail. Suppose there is a nail, or you can assume there is a some support. So when it is released from rest, so it come to this point in the same way. So what is the time period? Say t by 4, where t is what? 2 pi root L upon g. Now this length is 3L by 4. So what is this length now? This length become what? L by 4. Are you getting or not? And it become point of suspension. It oscillate like this. Are you getting or not? So if the length is L by 4, what is the time period t dash? Say 2 pi root L by 4 upon g. So this is equal to 1 upon 2 pi root L by g, because 1 by 4 square root is equal to 1 by 2. So it is t by 2. Are you getting or not? So from here, if it is released from rest, it oscillate for the length L, and after this it oscillate for the length L by 4. Are you getting? So the time period is supposed to be the t dash. So now the time period, this is t dash by 4, right? And this time period is again t dash by 4, and it become complete length and it move in this way. So this is t by 4. So what is the total time period? Total time period is, right, t by 4, t dash by 4, t dash by 4, t by 4. So it is equal to t by 4 plus t dash by 4 plus t dash by 4 plus t by 4 multiply by 2. So answer will be t by 2 plus t dash by 2. Fine. And what is the t dash? T dash is t by 2 upon 2. T by 2 plus t by 4 is equal to 3t by 4 is the correct answer. Right. So A option is the correct answer. Copy this. So read this question. In this question, there is an inclined plane and the angle of inclination is theta with the horizontal, and the mass is held by the spring. Right. If the mass is held by the spring and no friction is there, it means the mg sine theta is acting over here, right? And the kx naught will be acting this side. Is it clear or not? So the kx naught is equal to mg sine theta. This is the one condition for equilibrium. This is condition for equilibrium. Are you getting or not? Now what is happening if the mass is taken 2.5 centimeter up, right? The tension in the spring reduces to 0. Obviously, if it was the natural length of the spring and this is the extra elongation x naught, right? So when this mass is taken to this point, so now what is the spring force, right? If it is the natural length and because of this weight it moved down, and now this is the equilibrium position. Are you getting or not? This is the equilibrium position. So you tell me this x naught is given the 2.5 centimeter or not, you tell. Is it clear or not? So with the help of this, 0.25 is equal to m into g into sine 30, right? So this is k is equal to 25 into 1 by 2 divided by 0.25, right? So it will be 100 by 2, right? The spring constant is 15 Newton per meter. Are you getting or not? Right. So this is the question. Right. Now this block is released from rest. If this block is released from rest here, it will move down, right? Move down here. Because of the mg sine theta, it will move up and the velocity will be maximum, that it will move down, right? Like this. So if it is released from rest from here, right, it will oscillate about its mean position, and this is the mean position, right? So what is the time period? The time period is 2 pi root m upon k. That's it. 2 pi is, and what is m? The mass of the block is 2.5 kg, and the k we have found it is 50. So this is 2 pi root, right? This is 25 500, right? 20 5 20 pi by root 5 second. So this is the time period of oscillation, right? You can find the value, how much it is. T is equal to pi root 5, it is given. 2.5 25 बटे 500, 25 दूनी 500, बिल्कुल सही बात है. And find this value, 3.14, right? Oh, okay, they are asking the angular frequency. The angular frequency is 2 pi by t. So 2 pi by t is pi by root 5 it is, right? And this is the angular frequency in radian per second. So this is 2 root 5. So what is the root 5 value? It is 2.23, right? So 4.6 second. आंसर नहीं आ रहा इसमें. देखो, kx naught sin theta mass hinge along the surface of the incline. The mass angular frequency kx naught will be equal to mg sin 30, right? And k into x naught. Oh, this is 2.5 centimeter. It is equal to minus 2 meter, right? There is a mistake. So the k into this x naught is 2.5 into 10 to the power minus 2. Now please simplify. So this is equal to what? 2.5 will cancel out. K is equal to 10 into 1 by 2 upon 10 to the power minus 2. It is 500. So the spring constant comes to be 500 Newton per meter. Fine. Here I will put 500 Newton per meter. Fine. This is 2 pi root 2.5, right, divided by 5000, right? So this is 25 chokka 100. So 20 pi upon 20, it is pi by 10. So time period is pi by 10 second. Therefore angular frequency you may write 2 pi by pi upon 10. So it will cancel out. So it is how much? Speak loudly. 25 दूनी 50, right? So 2 pi by 10 or root 2. It is pi by 5 root 2, right? So it is 2 pi upon 5 upon root 2. So it is 10 root 2. And 10 into 1.41, it is 14.14 is the correct answer in radian per second. Is it clear or not, you tell? Copy this. So read this question. In this question, a ball of mass m is hanging by mass m, right? This is the mass m. So it was the natural length of the spring. So when you hang the ball, what will happen? The mg and the elongation in the spring will be equal to x naught. So at equilibrium, the kx naught will be equal to what? Equilibrium. Are you getting or not? So what is the value of x naught? Say mg by k, no doubt. You tell me, if you remove this, what will happen? Tell me. If you remove this ball, it will acquire its original length. So what is the length of the spring which is shortened? The ball oscillates with time t, the spring is shortened by. So therefore, spring is shortened by this distance. Are you getting or not? But it is given in terms of t, not in terms of k. So what was the time period of oscillation? If you give the small displacement, right, it will oscillate up down about this mean position, and with the time period 2 pi root m upon k. So t square upon 4 pi square is equal to m upon k. Are you getting or not? So this is the distance we have to find, m upon k into g. So what is the value of m upon k? It is equal to t square upon 4 pi square into g. So what is the answer? T square g upon 4 pi square. Is it correct or not, you tell? T square g upon 4 pi square. The A option is the correct option. Please check the answer. Actually, I could not understand what exactly you want. Listen one thing. There is no difference between the phasor diagram what I have explained. Listen. Initially, the spring was horizontal, right? Like this. Are you getting or not? For this, if you consider, if suppose this is the spring, right, and it is placed at horizontal, are you getting or not? So if this is the horizontal spring, the particle start from here, the block start from here. So you tell me, what is the phase of this particle? T is equal to 0, the phase is what? 0. When it move down, right, the corresponding, when the particle move down on the circle, uniform circular motion, this particle, this block reaches to this point or not, you tell? So what is the phase covered by the particle, phase covered by this block? Say pi by 2. Is it clear or not? So what is the phase of this block at this point? The phase is pi by 2, right? When this particle come to this position like this, it is moving, then it move in this way. Are you getting? So what is the phase? Here, again it cover more phase, pi by 2. What is the phase at this point? Pi. Now you know everything very well. If this point reaches to this point, right, the phase is what? 3 pi by 2. When it reaches to this point, so this is 2 pi. That's it. Pi by 2, pi by 2. Understood or not this figure? Now if you take the vertical oscillation, suppose this is the spring, right? If this is the spring, suppose this is the mean position, right? And if it is the plus A, or you can assume this is the plus A or minus A, whatever you assume. When it is oscillating, you have to tell the phase. All right. So for this thing, you have to make a circle like this. Are you getting or not? So when suppose this is the plus A, this is the minus A, plus A minus A may be change, but let me check what is given here. In that case, leave that. Okay, this is the thing. If you assume this is the plus A, listen, at t is equal to 0, the particle is moving, suppose the block is moving downward. So where is the corresponding particle on the circle motion, you tell? At which point will be this? 1, 2, 3, 4. 1, 2, 3, 4. Tell me. Yes, 2. Right? This is the particle. So now, if you are considering this motion, right? So this particle start from here only. Are you getting or not? So this is the initial phase you will assume to be 0. Are you getting or not? Now if it is moving down, so this particle is moving in this way. Are you getting or not? So what the phase is covered? Pi by 2. So what is the phase at this point? Pi by 2. When it comes down, when it move further and this particle move again, right, block move again, it reaches to this point. Is it clear or not? So what is the phase when it is moving back? Pi. And what is the phase at this point? Tell me. 3 pi by 2. When it come back, what is the pi phase? 2 pi. Are you getting or not? So if it is moving up and down like this, so it is covering the phase. It means whether it is horizontally performing oscillation horizontally or vertically, the thing is same. The corresponding particle on the circle is performing uniform circular motion, right? Horizontal uniform circular motion is performed by this corresponding particle on circle, and you can find the phase. Is it clear or not, you tell? So this is given only on that page. Please tell me, copy this. So read this question. In this question, the particle is performing SHM. This is the mean position, right? This is the plus A, this is the minus A. The particle is over here minus A by 2, and it has to reach plus A by 2. Sorry, plus A by 2 to minus A by 2. Are you getting or not? So if you take the this direction is the y and this direction is there, it become minus y. So you tell me, if this is A by 2, what is this time period I told you? T by 12. And what is this time period? Say T by 12. Are you getting or not? So what is the total time? T by 6 is the correct answer. T by 12 plus T by 6. Check the answer. Is it correct or not, you tell? Varsha. Because listen one thing. So this is SHM, right? In a different way, the question can be solved. They have made a corresponding circle, right? How it is like this. Suppose the particle start from motion here. So where is the particle? Corresponding particle like this. When it is moving like this. When over here, this is particle over here. When over here, the particle is over. Is it clear or not, you tell? So this is the angle and this is also the angle. Are you getting or not? So if it is distance is A by 2, this is A, right? So this angle is what? Say 30 pi by 6. Tell me, pi by 6 or not? So this angle is pi by 6. So you tell me, from here to here, what phase angle he covered? From here to here, what phase angle he covered? Tell. Pi by 3. The angle covered by this corresponding particle on the cycle is pi by 6 plus pi by 3. So theta is equal to what? Say omega t. Theta is pi by 3. Omega is 2 pi by t into t. So what is the t? T is equal to t by 6 is the correct answer. Is it clear or not? But for A by 2, we have remembered that it is T by 12, it is T by, right, 6 like this. So if they ask, then we can do directly. Also with the help of this, we can do in this way. You understand both method or not? Without phase, how we solve this? From here to here, the x is equal to A sin omega t, you can assume. If you want to find this time period, from here to here, whether it is moving up or down, the time is taken same. So if this displacement is 0, now you will write the equation as a function of y, because it is moving in the y direction. So what is the displacement y? A by 2, it is equal to A into sin omega t. So it is 1 by 2 sin omega t. It is sin pi by 6. Pi by 6 is equal to omega into t. So pi by 6 is equal to 2 pi by t into t. So t is equal to t by 12. So how we get this t by 12? And this is also t by 12. So t by 12 plus t by 12 is equal to t by 6. This is only the answer. This is the Phasor method. Copy this. Instead of this, suppose I'm asking you, suppose there is a spring, right? This is the mean position, right? This is the mean position and there is a spring, right? It is the mean position, suppose, and this is the plus A, this is the minus A. What does it mean? It is plus A and it is minus A. So when it will move, What will be the phase at this point, util? At this point, it is moving up, down, up, down, up, down. If it is plus A, what will be the phase at this point, util? Tell me. This is the plus A. It start from here, go like this, come to the down point, then it move up. So what is the phase, initial phase over here? 0. Then if it cover the 1/4 1/4, right, oscillation, what is the phase at this point? Pi by 2. So can you make the corresponding particle on the circle? So at t is equal to 0, where will be the particle, util? 1, 2, 3 or 4. So it is, tell me. At 2, so it is moving like this. Yes, you can assume in this way also. So if it is start from here, the particle start from here, right? So this is the phi angle, right, theta. So when it reaches to this point, right, the particle is over here, so this phase is phi by 2. Are you getting or not, util? Right, then it come back, it move this. So what is the phase angle? Say again pi by 2. Are you getting or not? It come this point. So what is the further phase? This is the phase, right? 3 pi by 2 over here. When it come back, again pi by 2. So it may be like this. Also sometime the corresponding particle you can make over here, but generally they take at this point. So the anti-clockwise particle start doing motion. Are you getting? So in this way, in the vertical, whether it is vertical, whether it is horizontal, so you can take, listen one more thing, only the thing is that if 0 is this side and the plus A is this side, so we will consider the particle is going in this direction and it is pi by 2. In the previous case when I explained, I had taken the minus plus A this side and the minus A this side. It may be the case, right? It is not necessary the y-axis is always up. In this case, y-axis is vertically down. So then particle start the phase initial 0, then reaches at this point, it is pi by 2, then it is pi, then it is 3 pi by 2, then it come back, right? So it become 2 pi again. Are you getting or not? Like this. So when it is moving down, you can take the particle in the clockwise direction. For this particle, if it is moving down, up, down, so the corresponding particle will move anti-clockwise sense. It is not necessary to move the particle every time the clockwise or anti-clockwise. So you have to check how it is plus A and minus A given. How it is plus A and minus A is given. But generally, it is the mean position, it is plus A, it is minus A, right? And if it is the mean position, y is equal to 0, it is plus A and it is minus A, because we assume the y direction in upward direction. So it is like this. So corresponding particle on the circle start from this point and perform uniform circular motion in this way. So you have to understand this. Copy this whatever you want.